So going back to the whiteboard, we said that we wanted to plug it into f of t. So we've got f of t star g of t, integral from 0 to t minus tau, e to the a tau d tau. This is the way I did it on my piece of paper, by the way. Integral from 0 to t minus tau, e to the a tau d tau. Let's distribute both pieces of that, and then we'll deal with two integrals separately. So we've got integral from 0 to t e to the a tau, and I'll pull the minus out in front also. Integral from 0 to t tau, e to the a tau d tau. So t, e to the a tau, d tau, I forgot my d tau there. Let's see if I can squish it in. It's d tau minus tau, e to the a tau d tau. Okay, first integral isn't so bad because I'm integrating with respect to tau, and t is just a constant with respect to tau. So this one isn't too bad. We'll do this one over here. If I integrate e to the a tau, that gives me a 1 over a, right? Thinking about UU substitution. So we're going to have t over a e to the a tau evaluated from 0 to t. You got a 1 over a when you do your integration of e to the a tau, and then that t out in front is just a constant with respect to tau. I can plug in t, I can plug in 0, so we can do t over a e to the at minus t over a e to the 0. And so this first integral is t over a e to the at minus t over a. That's the first one. All right. Second one is messier, sorry. Second one, you have tau times e to the a tau, and that's gonna need integration by parts. Yup, I can only see 3 of you, but the 3 of you I can see you're making faces. So integration by parts, u equals tau, dv equals e to the a tau d tau. du is then d tau, and v is 1 over a e to the a tau. Okay, I'm going to leave the minus in the middle off. We're just going to subtract the 2 answers that we get when we do the second one. So we've got an answer for the first integral, we're going to get an answer for the second integral, and then we're going to subtract them. So I'm leaving the minus off for just a minute. Okay, so we have uv, so tau 1 over a e to the a tau minus the integral of v du, so minus 1 over a e to the a tau d tau. uv minus the integral of v du. uv minus the integral of v du. We can do some combining. And so this is going to be tau over a e to the a tau minus, when I do an integral of this, I'm going to get another a in the bottom. So minus 1 over a squared e to the a tau, and this is evaluated from 0 to t. So tau over e to the a tau minus 1 over a squared e to the a tau evaluated from 0 to t. If we do some plugging in here, we are going to get t over a e to the at minus 1 over a squared e to the at minus the quantity t over a e to the 0 minus 1 over a squared e to the 0. So t over a e to the at minus 1 over a squared e to the at minus, t over a e to the 0 minus 1 over a squared e to the 0. Stuart, question?
Wouldn't you, when you're plugging in the 0, plug it in for tau over A? So it'd be 0
Yes,
over A.
yes, yes, yes. Thank you. Sorry. Yes, this is not a t. I don't want to plug in a t here. I want to plug in a 0. So 0 over A. Thank you. My bad. 0 over A. So then this first part inside the parentheses totally goes away. That part 0. And then the second part is negative 1 over A squared. So I've got two negatives that become a positive. We've got t over A, e to the at, minus 1 over A squared, e to the at, plus 1 over A squared. So I've got a plus there. Okay. Last thing, I need to subtract both of these pieces that I have. So my final general answer, over here, for f of t star g of t. I need my first piece, that's t over a, e to the at minus t over a, minus my second piece. Can I just do changing the sign of everything that I have in my second piece instead of putting a minus in parentheses? Can I just do it that way? So in other words, we're going to have minus t over a e to the at plus 1 over a squared e to the at plus 1 over a squared minus 1 over a squared minus 1 over a squared. E to the at minus 1 over a squared. Okay, the first piece and the third piece go away. Those cancel. And then I end up with, we can write it in any order that we want. So negative t over a plus 1 over a squared e to the at minus 1 over a squared. And that is what I have on my piece of paper, which is good. So there's my answer for the convolution of f and g. Negative t over a plus 1 over a squared e to the at minus 1 over a squared. Okay, I am going to bring you back together and you are going to tell me, Zach has a question before I go my whiteboard away. Zach, yes?
Why did the signs flip on the second?
Yep, because if you go back to the two integrals that we had, there is a minus in the middle of those two integrals, right? So I needed to subtract the second piece, and so I just flipped all the signs instead of putting parentheses around the second piece and subtracting. Do you see it? Does that make sense? Okay. Anybody else? Other questions before I stop sharing my whiteboard? Anything else there? Okay, let me bring you back together for just a second. So how are we doing? Besides the fact that you really don't like this because it's a messy integral, and I understand that you're not wild about it, and that's okay. We can live with that. Does the process of finding a convolution make sense? Process? Are we good? Process of finding a convolution, even if you don't really like doing it and it's going to be integration by parts and it's going to be yucky? Yes. All right. So let's talk then about how this is useful in differential